popular math questions. These questions range from anywhere from the high school to university level questions, and some might be a bit junior questions as well. A little bit about myself. I'm actually a mechanical engineering graduate from the University of Waterloo. I graduated in 2018. I've been working for the past 2.5 years, and then I decided that I will be pursuing my master's degree in mechanical engineering. So I'll be starting that in 2021. I'll be doing that from the University of Toronto. So looking forward to that. All right, let's dive into the questions. So the first question is actually a question which is based on permutation and combinations. In the first question, we're given a set of alphabets. So from A to all the way to H. So there are 8 alphabets. And we've been asked how many 5-letter passwords we can create from these, and repetition is allowed. What repetition is allowed means is that I can use the alphabet A multiple times. So one of the 5-letter passwords could be AAAAA, so 5 times A. So one of the key formulas which we need to know for solving the first part of this question is when we have repetition is allowed, we have a formula for n choose r which we can use. So the formula goes as follows. So n choose r is equals to n plus r minus 1 exclamation mark. This exclamation mark means all of this is a factorial divided by r factorial multiplied by n minus 1 factorial. Okay, this formula is pretty standard, and I'm fairly sure all of you would be familiar with this formula. Here, n is the total number of choices we have. So we have 8 choices, 8 alphabets. So we can say n. Okay, I'll just rewrite that. So n is equals to 8, and then r is equals to 5. I selected r equals to 5 because those are the number of letters which we are picking for our password. So essentially what we're doing is we have a list of 8 alphabets which we are picking 5 from for our password. So we're picking from there. Okay, now in order to do that, we can plug these numbers into the formula, and then we should be able to get our answers quite easily. So n choose r of n equals to 8 and r equals to 5 gives us 8 plus 5 minus 1 factorial divided by 5 factorial times 8 minus 1, so that's 7 factorial. So we're just going to simplify it in the next step. One more thing which you can do is you can so one more thing which you can do, which will help you track your answer, is replace the n and r in these in the left side of the equation as well. So that will give us 8c5 is equals to, so on the right hand side, 8 plus 5 is 13 minus 1 is 12, so 12 factorial divided by 5 factorial times 8 minus 1 is 7 factorial, so 7 factorial. So now we have to simplify this equation and get the final answer. I'm sure all of you are familiar with the concept of a factorial, but in case some of you aren't, factorial is essentially the number multiplied by all the numbers starting from that number to 1. So basically what that means is 3 factorial would basically be equal to 3 times 2 times 1. So in that similar fashion, we can say 12 factorial. So in order to simplify the left hand side, or sorry, the right hand side, 8 choose 5 equals to 12 times 13, so 11 times 10, all the way up to 1. Okay, and similarly, this 5 factorial will become 5 times 4 times 3 times 2 times 1, and then the 7 factorial would become similarly 7 times 6 all the way to 1. Okay, so one quick trick which you can do is, if you notice, the 12 factorial will also have all the terms which are in the 7 factorial. So these two would cancel out. So the one way of representing this right hand side would be if you cancel this out with all the numbers from 7 to 1 on the numerator end. So that will leave us with 12 times 11 times 10 times 9 times 8, and then the rest of the numbers cancel out from the denominator, and then on the denominator side the 7 factorial portion goes away. We're only left with 5 times 4 times 3 times 2. So now if we were to solve for this, we would get, let me just quickly punch these numbers into my calculators. 12 times 11 times 10 times 9 times 8 divided by 5 times 4 times 3 times 2. Okay, so the final answer we get in this case is 792, which basically means that if we're given 8 alphabets and we have to make 5 passwords from those 8 alphabets, we have to make passwords of only 5 alphabet numbers, then we can make 792 passwords. So similarly, now that we've done this first question, the second question should be somewhat easier to do. So the second question goes, a city council with 9 members must appoint a leadership team consisting of mayor, treasurer, a secretary. How many teams are possible? So if you notice carefully, there are 3 positions which we need to fill: a mayor, a treasurer, and a secretary. So right off the bat, we know our n, which is the total number of choices we have, is 9, since we have 9 city council members, and we have to fill 3 positions, so our r becomes 3. Now one thing to note which is different from the question above is that in this case we actually can't repeat people. So if someone's a mayor, they cannot be the treasurer as well. Similarly, if someone's a treasurer, they cannot become the secretary. So here we'll be using the formula for NCR and choose R without repetitions. So the formula goes as follows. So N choose R is equals to N factorial over R factorial multiplied by N minus R factorial. So again, we know our N and R's, so we can fill those in. So we would get 9 factorial divided by 3 factorial times 6 factorial. So similar to what we did in the question above, we can simplify the 9 factorial in terms of cancelling out the 6 factorial. So we can write this as 9 times 8 times 7, the rest gets cancelled out, divided by 3 factorial, which is 3 times 2 times 1, but it doesn't make a difference, as you know. So the answer to this question would be The answer to this question will be 84. We can make 84 such combinations. All right, let's just make sure this will answer it correctly. So 792, so that's correct. And 84 team combinations. That's perfect. And they have given the explanation just like me, with the factorials cancelling out and how to simplify. So the answer is correct. All right. So the next question is actually a bit focused on data management side of things. So the question first part asks us for a data value that is much higher or lower than the other data values is known as blank. So we need to fill the blank. So the answer to the question is an outlier. So I'm going to explain what an outlier is. Actually, I'm going to go to a new page just so it's clear. So the answer was an outlier. So what exactly is an outlier? An outlier is something, a data point in a data set which falls drastically away from the other data. So for example, if I have a data set X, which is a result of students who have taken an exam, and we have the average score out of 50 was typically, let's say, 40, 37, 45. So all these numbers are fairly close to, let's say, each other out of 50. But then if we have, let's say, a 7, so this 7 becomes an outlier since it's very different from the other data which we have. So this would cause a bit of a skewness. What a skewness means is it'll cause a shift when we try and plot the data. So if I were to plot a histogram of this data set, basically what it would look like is, okay, let me just try that again. Okay, much better. So we would have, let's say, our number 5 here, 10, 15, 20, and so on. And we would have our, let's say, 35 and 45 here. So we would see that around the 7 and 10 region, we have a small blip representing the 7 in our data set, and then the rest of the data is typically around the 35 to 45 range. So we have, let's say, a bigger bar here. So when we look at this data as a whole, we would see that the majority of the data is clustered around 35 and 45, but then we have an outlier in the data set. Now this outlier can be on either side. It doesn't have to be on the left side of the data, it can be on the right side as well. So that's one way of visualizing the outlier. Now if we go to the second question, asks us to calculate the standard deviation of the data set. Okay, so this formula for standard deviation is as follows. So number 2, standard deviation is represented by the Greek symbol sigma, and the formula for standard deviation is square root of the sum of all the values minus their mean of the data set squared divided by n minus 1, where n is the total number of values in the data set. Now x would represent all the values which we have in the data set. So in this case 1, 3, 3 and 5, and x bar is the mean. So first we can calculate the mean of the data set. So the mean of the data set is basically the sum of all the values divided by the total number of values. So in our case, it will be 1 plus 3 plus 3 plus 5 divided by 4, which is the total number of values. So 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 1 is 4, 12, 12 divided by 4 is 3. So our mean is 3. Now if we were to calculate, if we would plug that in our equation above, what we would get is sigma is equals to, I'm going to write out the entire sum so that it's clear. So this sigma up top essentially represents the sum of all the values. So the sum of all the values would mean we would have 4 values representing our 4 points in the data set divided by n minus 1. N is 4, so we're dividing by 3. Now what are these 4 values? These 4 values would be each of our point minus the mean squared. So this would be 1 minus 3 squared. The second would be 3 minus 3 squared. Third one is also 3 minus 3 squared. And finally the last one is 5 minus 3 squared. So the question made it quite easy for us by giving us mean equal to the values in 2 of the cases. So those basically become 0, as you know, and we can calculate the remaining values. So sigma is equals to, what we would be left with is 1 minus 3 is 2, squared is 4, plus 5 minus 3 is also 2, squared is 4, divided by 3. So we will be left with under root 8 over 3 as the final answer for our standard deviation. Now just to give you sort of a feel for what standard deviation is, so standard deviation would somewhat help us visualize how our data varies, how each point varies from the mean of the data. So in this case, the mean of the data was 3, so our standard deviation is roughly 8 over 3 square root. So all the data points on average vary by that much. So now if we just want to calculate the final value, so that is approximately 1.63 is our standard deviation. Alright, so they have correctly outlined that outliers are the data and they are caused by experimental errors or just some wrong data, in some cases errors while correcting the data. And for the second question, the answer was 8 over 3, which is also 1.63. Both the answers. Okay, so now we'll get into the third question. Third question is more so probability based. So we'll need to know a few basic principles of probabilities, which we'll quickly revise. So the probability of any event occurring is equal to the probability of that event divided by the total number of events. So the probability of any function happening x is number of times that events occur. Event can occur divided by total number of events. So with that in mind, we can look at the first question. The first question gives us a bag which consists of 3 red, 4 blue, and 4 green balls. Okay. So question 1, we have a bag in which we have 3 red. So 3 times red and 4 times blue and 2 times green balls. What is the probability that on a single drop you get a red ball? So now if we were to put our hand in this bag, what is the chance of us getting a red ball on our first trial? Now the way to look at this question is, first we can identify what the denominator would be. So the denominator is the total number of events. In this case, it's the total number of balls we have in the bag. So the total number of balls is 4 plus 2 plus 3. So that's the total number of balls. We have 9 balls. Now, number of times which our event, which in this case is of getting a red ball, would be a success, is the total number of red balls. So that's 3. So in our case, the probability of getting a red ball equal to, so as we said, there are 3 red balls, so 3 divided by the total number of balls, which is 9. So this is also equal to 1 over 3. So we have a 33% chance that if we put our hand in the bag, we'll get a red ball. Okay. B, if a family has 3 children, what is the probability that a family has exactly 2 boys? Assume that having a boy is as likely as having a girl. Okay. So they have 3 children. So the first thing we have to look at is what are the total number of outcomes which we can have. So if I have 3 blank spaces in a family, let's say, I can fill each of this blank space 2 ways. So I can either pick up girl, boy, girl, boy, girl, boy. So since I can fill all of these in 2 ways, I can say basically I have 2 to the power of 3 ways that I can generate the set of 3 siblings, or 8 ways. Now, the easiest way to do this question is to just look at the number of combinations which would give us exactly 2 boys. So if we start off by saying boy, 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 so we have 3 boys. Then let's replace 1 with a girl. Now, if let's say we're arranging these siblings in order of descending age, so the biggest one is at the top. If we move this girl to second position, there will be a different set of siblings. So we have to consider that as well. So this is another way. And then G, B, 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 G, 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 B, G, 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 B, and then G, G, G. So all 3 girls. So if we count here, these are the 8 possible outcomes which we had initially calculated. Now, out of these 8, which ones have 3 or 2 boys? So if we notice carefully, there are these 3 which have 2 boys. So therefore, our probability of having exactly 2 boys in a family of 3 siblings would be 3 divided by 8. Since 3 is the number of cases which we got from here, and then 8 is the total number of possibilities. Alright, I hope that was clear. So next question, we will roll a fair six-sided die and we'll calculate the odds against rolling a 5. So one important thing to note here is that the question is asking for odds and not, let's say, the probability of getting a 5 or not getting a 5. So with that in mind, so it's a fair sided die. What means by that is probability of any number being rolled is equals to 1 over 6, since there are 6 sides in a die. Now, what is the probability that we roll a 5? Since 5 is just one number, it is equal to 1 over 6, the probability of rolling a 5. To calculate the odds against, we need to calculate the other end of this probability as well. So what that probability would be is probability of not rolling a 5. So that probability would be equal to 1 minus p of 5, or it will be equal to 5 over 6. Now to calculate the odds, we have to divide the two. So we have to divide p of 5 with p of not rolling a 5. So that will give us 1 over 6 divided by 5 over 6, or it will give us the odds to be 1:5. Okay. So for the first question, they got 1 over 3, which is correct. The second question, the answer was 3 over 8, which is also what we got. Perfect. And then for the final question, the answer was 1:5. So I would only recommend that the odds should be represented as a ratio as opposed to a fraction. Answers to all the questions. Okay. All right. So on to our next question. How do you use the power reduction formulas to rewrite the expression for cos to the power of 4x in terms of first power of cosine? Okay. So question 4. So we need to know for this question one of the most commonly used trigonometric equation for cos 2x, which basically goes as follows. So question 4, we can write cos 2x in terms of, well, firstly the question. So we need to represent cos 4 of x in terms of cos of x. So we need to get rid of the power raised to 4 and get it to the first power of x. So the way we would do that is first we would look at the formula for cos 2x. So cos 2x equal to 2 cos square x minus 1. So we know that we are already one step closer to the cos 4x because we had cos square x. So now if we simplify for cos square x, we would get cos square x is equals to, the negative 1 goes to the other side and the 2 gets divided. So we'll have cos 2x plus 1 divided by 2. Okay. From here, we need to know that if we square this, we would get cos 4x, and we would have to square this entire function. But it's important to note that here we have cos 2x, but we want to represent the cos 4x in terms of cos x and not cos 2x. So what we can do is we can, from here, we can see what cos x would be. So we'll get to that step in a second. So if we square both sides of this equation, you would get cos 4x is equals to cos 2x plus 1 divided by 2 whole square. Okay. Now just coming down a bit, I'm not going to write the left hand side. We can say that this would be 1 over 4 cos 2x plus 1 squared. Now, as we know, that cos 2x, as we wrote previously above, is nothing but, let me try and get that for you. So cos 2x is nothing but 2 cos square x plus 1. So we can use that equation in our right hand side in order to further simplify this. 1 over 4 actually it'll be easier if we use it once we square it, so let's do that. So if we square this, we get cos square 2x plus 1 plus 2 cos 2x. Write a bit small in the line below. As we said, cos 2x we can get from the equation above, so we will substitute that in. Let me just revisit that quickly. So essentially what cos square x would be is if we replaced the x on this equation with 2x. So we would get cos 2 cos squared 2x minus 1 equal to cos of 4x basically. So if I were to put that down, cos 4x plus 1 divided by 2 plus 1 plus 2 cos 2x. Okay, now let's keep going down. Now we're fairly close to our final answer. So our final answer would be equal to 1 over 4. Let's simplify everything in the bracket first. So 4 divided by 2. 2 gets multiplied there. So we get cos 4x